On folks, trying to keep you guys updated here on all the things that we're doing. So we have 6 of the Grow Watt series inverters. We have a hybrid system. So basically what I'm trying to do here is we have 3 inverters that I'll be doing power output for the EG4 platform, which is 60 kW or 12 of these batteries. We got 6 in bay 1 and bay 2. We have the other 6. So what I'm doing here is I have 3 of the bottom inverters that are going to be doing for power output. The other 3 will be basically for backup. Why that is for 2 reasons. A, I don't want to beat down the system as much as possible, especially when we can use grid tie. This isn't absolutely a doomsday scenario yet, but we have the option and capability to be able to switch over easily, right? So 3 of the inverters are going to be off-grid, powering the house, the power output. We have 2 of the transformers sitting here, the Grow Watt series, 7200 watt. Battery bank has jumped from bank to bank with this junction box sitting here at the bottom, as you can see, with the flex tube going into the actual cabinet. We have inverter 1, 2, 3, 4, 5, 6, all sitting on this section here. Sorry, we're not labeled yet. Getting close. Transformer 1 and 2. That powers that's where the power substation is going to be coming from, right? And we are, all our 54 solar panels coming there. Dragged line coming up through here, going into this junction box. This junction box goes directly right to the inverter, which is the 3 inverters that you see on the other side. We're powering this grid tie inverter with those remaining legs. As you can tell here, you have to put a meter in place, I think for TVAC and a couple other places. So we have L1, L2, neutral, and ground going into their corresponding spots. Now, if you're going to have somebody wire this up, the way that they have this is that this is power output. So this has to go on the bottom part of the meter, okay? Because he isn't supplying power, he is just generating power. So he has to come into the bottom part of the meter. The top end part of the meter has to come from a breaker or a disconnect. So that's always line feeding into the system here. So where that goes is comes up into this disconnect right here. So we have L1, L2, neutral, and ground. I use a 3-phase disconnect just so I can actually disconnect the actual neutral. And that goes on the off-grid application as well. I always use 3-phase. I don't like to use single-phase 240. It's just, it allows me to have absolute control of our system here. So anyways, then the power coming fed into the system, which you see here, there's supposed to be a meter and a incoming main power supply coming into this. We will be jumping into the top end part of here, coming from a breaker over here, 50, 60 amp, 63 amp, so 42 max. So we need a 60 amp current. We have 4-gauge wire, which is about 85 amp current, so that covers us in all directions. We only need to run number 6, but we ran number 4 just to make sure that this thing was supposed to do what it's supposed to do. So yeah, you on certain places here, you have to have the meter in place in order for you to do net metering itself, just so they can supply extra verification of how much power is being supplied into the system and how much they can rob you. That's why we're doing the grid and the hybrid system with the off-grid application. Of course, you see in the 54 solar panels, they're sitting over here, sitting on the ground mount, ran into 9 in the configuration. There are 6 lines coming in total. Okay, so with that being all said, we have the power output. We had to run lines going into the attic to our main central hub. Now, their main central hub is still under construction, as you can tell. So we had to pull out what lines that we wanted. Everything was already verified. So like this one here is the game room downstairs bath. We ran as many of the lines that were needed plus well to be able to transfer over here. Now, this was a tight spot. I didn't want to put all my equipment up here. I'm a pretty tall guy, and I don't want to be coming up here, flipping switches over a top end part of the breaker. So we brought everything a little bit lower, easier to manage. You come in here, and here's all your 20 amp services. It's not 100% tied down yet. Literally, is making the video. as I'm about to leave, go pick up some other things here. Okay, so we have our main transfer switch coming in for neutral, coming into the side. Power output is coming from solar itself, which is this line here, L1, L2, and then you got your neutral, you got your ground coming over here, and we still need to bond these two panels together. So got about an hour's worth of work. Almost there. Very excited. Can't wait for the next job we're doing. There's 36 solar panels on this bad boy. I'm sorry. 36 batteries, 12 inverters, 2 transfer switches, all on the same job. This is a 7,500 square foot home, as you can tell. Well, you can't really tell, but anyways, it's under construction. Massive, massive home. The one that we'll be doing next is roughly about 9,500 square foot. So very excited to keep you guys updated on that progress. I'll keep you another, make one more video on operations when this house is up and ready to go. Other than that, thank you. God bless.